so which will be calculated using this thing. Then I am calculating all the required parameters. I'm fixing the frame size. I am finding the EB by N naught. You know, EB by N naught is the performance measure for a digital modulation. Same to SNR, we'll be finding the EB by N naught. Then you find the error status and then you run the code for every EB by N naught. For one till how much ever EB by N naught is there, run the code, transmit. See here, data, I am generating random data, I am modulating QPSK, I am modulating by OFDM, I am calculating the power, I am sending it. Receiver, you see, a channel is adding transmitted signal plus noise. And in the receiver, you see, this signal, received signal is first OFDM demodulated, then it is then QPSK demodulated, then I'm finding out the error. I am comparing whether what I sent is what I received. Then if it is so, I don't add error. Otherwise, I'll be adding the error. Finally, I'm plotting the BER. This is the entire thing. It is simplified in a very few lines of code because we have all these ready-made blocks ready in MATLAB: QPSK modulator, QPSK demodulator, OFDM modulator, and OFDM demodulator. Because of all these functions we are having, we are making it very, very simple. And when I run this graph, when I run this complete MATLAB program, can find the final graph here. They are plotting two graphs. One is between simulation and theory. Simulation is what we do practically by sending data and decoding at the receiver and doing, and theory is what is given in the formulas. And we find that whatever given in theory is very closely matching. And see the answer here. The star is going to be the simulation what we have got ideally by sending and receiving signals, and the red color is going to be the theory. And we can see a close thing is gone, and you know that bit error rate should be as small as possible. And even though you have a very high SNR of 10 EB by N naught, bit error rate is only close to 10 power minus 5. That is because in wireless medium, BER is very, very poor because you have multi-path propagation. You don't know where the signal is going, which path it is taking. We cannot predict that in wireless communication. So we have this effect of channel fading and other noise adding into your signal. So wireless medium always has a poor BER. So even though SNR is 10 dB, your BER is 10 power minus 5, which is what is the meaning of 10 power minus 5? If I send 1 lakh bit, 1 bit is going to have error. So 1 by 10 power 5 is going to be 10 power minus 5. So the only system which is going to have a very, very less BER will be optical fiber cable. It has a BER of 10 power minus 12. So if I send 10 power 12 bits, 1 bit only will have error. That such is the accuracy of your optical fiber based communication system. Wireless systems always have this drawback of having least BER because of channel constraints and also the type of modulation you are going to use. I am going to combine QPSK and OFDM, right? So that is more number of components you have. Naturally, power loss will be there. That is also one of the reason for the BER becoming very, very high. Okay, so this is one example I wanted to show you how just by using the various blocks we have in MATLAB, we can recreate OFDM based modulation using MATLAB at high frequency. Okay, and all these OFDM and all will be working at 2.45 gigahertz only. Whatever I told you, it is called as ISM band, right? So we'll be using them at ISM band only.